Okay, welcome back, everyone. Hope you enjoyed the lunch. So we're going to kick it off with our lightning session here. So I think there's, I don't know, 8 or 10 lightning speakers. If you're a speaker, why don't you go ahead and like start trickling down, maybe line up on the side here, just so we can do this rapid fire. So we're going to do, every speaker is allowed 1 minute. If you go over, 61 seconds, no problem. At 62 seconds, so expect me hovering over you. And then at 63 seconds, expect me to get off the big hook. We have to be really rapid fire. You get the experience. So make sure you say who you are. Make sure you say what the title is. But then, it's up to you beyond that. Conveniently, all the posters are just around the corner. So, it'll be we'll be able to track all the speakers down. Okay, so without any further ado, we have our first lightning speaker. Advance. Nope. Okay. Ben, why don't you step up?
All right. Hello, I'm Ben Vizzier. I'm a program manager at UCSC. I oversee both Dockstore and UCSC Data Explorer, which y'all know as the AnVIL Data Explorer. Dockstore is a workflow registry and sharing service jointly developed by the Ontario Institute of Cancer Research and the University of California, Santa Cruz. The Broad Institute provides significant contributions around the development of interfaces and interactions with cloud platform providers. We support Widow, Galaxy, CWL, Nextflow, Jupyter Notebooks, and we just started implementing StankMate support. We have over 5,500 workflows registered. We can launch into Terra, Galaxy instances, Valsera instances, DNA Stack, and DNA Nexus. We support J4GH's WES workflow execution service. For source control, we interface with GitHub, Bitbucket, and GitLab. And for containers, Quay, Docker Hub, and Amazon ECR. The past few releases have shown significant improvements in search results with term context, execution and validation metrics. This is huge. This is workflow integrity. And also automatic DOI generation. We've also implemented AI-generated topic sentences and suggestions and workflow and Dockstore.yaml inference.
Woo! Perfect. Next up.
Okay, hello. Thanks for this opportunity. My name is Narvaez from Moffitt Cancer Center. And today I briefly present our work on developing reproducible Galaxy workflow for the AnVIL. Our goal is to develop a suite of Galaxy workflows that analyze data hosted in AnVIL. Galaxy is a web-based platform for accessible and reproducible biomedical research. At SweetCase, we focus on predicting biological age using RNA-seq data from GTest platform. We preprocess the data using Jupyter Notebook within AnVIL workspace, and we trained the model using tabular learner and Logbin from Galaxy. We tested the models across 3 tissues, all tissues, breast tissues, and lung. The breast model performed best with an IUC of 0.60, while for the other models dropped the accuracy, suggesting that gene expression variability with the age. Overall, our work shows that Galaxy integrates efficiently within AnVIL. Thank you.
My name is Kate Isaac, and I'm from Fred Hutch and the AnVIL Outreach Team, and my poster is talking about insights from the 2024 AnVIL Community Poll. So the AnVIL Outreach Team, in coordination with other members throughout the other working groups, designed, distributed, and analyzed the results of the AnVIL Community Poll. So we started by asking all respondents to answer what their current usage is like, and that way we could decide if they were a returning user of the AnVIL or a potential user. And returning users got asked specific questions about their history with the platform and questions that potential users wouldn't be able to answer. And we really wanted to know about user experiences, barriers to platform adoption, technological comfort, a bunch of cool aims, things like what features they care about most. So if you come to my poster, you'll see more results like the one there that looks at the feature importance and looks at it compared to returning users versus potential users. And then we share some takeaways and next steps that we might take as an outreach team because of these takeaways. So this will be a preprint soon, and we would like to share it with the community first. And so if you have any insights, questions, things you have thoughts, I would love to hear them. Come see me at poster number 4.
Next up, Michelle.
Hi, so my name is Michelle Savage. I'm a software engineer at Hopkins. I work on the Galaxy project for AnVIL and beyond. And I have a poster that is basically trying to improve the tool testing experience for Galaxy users in AnVIL. And right now we're doing a very kind of base level, looking at the tool test scripts and improving those that run. On the left, you'll see a output from the existing README file, which is logging all of those tool tests. And on the right is the sort of improved version, which shows more of a longitudinal view, so we can tell when a tool is failing individually or systemically, and it's a longer-term issue. You can see by the continuous red squares versus some of the rows that just have one red square. We are also looking at porting this into some of the job errors into our job wizard AI so that we can get more clarity on the summary of that information. If you're interested in tool testing, if you are interested in improving tools around Galaxy, come see me in my poster. Also, I have another poster that's right next to this one. This is all about machine learning and AI in Galaxy.
Hi, everyone. My name is Mike Lopez from NHGRI. So the National Human Genome Research Institute has been at the forefront of genomics since its inception. From the Human Genome Project to the Telomere to Telomere Consortium, these landmark efforts produced high-quality, publicly available data that allowed researchers worldwide to bring their own perspectives, questions, and answers to the genomics community. That same spirit of openness drives RFA HG25005, enhancing the reuse of NHGRI data assets. This opportunity is about maximizing the value of data we already have, making it more discoverable, interoperable, and impactful. By reusing and reimagining these assets, we can accelerate discovery, broaden participation, and ensure NHGRI's investments continue to fuel transformative and open science. If you have any innovative ideas for data reuse, I'd love to connect. Please visit me at poster number 7.
Hi, everybody. I'm Natalie Kucher. I'm part of the Hopkins team. Come visit me at poster number 8. I'm going to be talking about training and education in AnVIL using the cloud. So we heard a little bit about some awesome science today, this morning, and I'm really happy to hear that that included some work with undergraduate students. So we're really thrilled about using AnVIL not only for, kind of the latest science of the most advanced researchers we have in the room today, but also training up the next generation. So we're talking at my poster about the advantages of using the cloud for training. So what AnVIL kind of augments in this experience is that you're able to bridge the use of this platform to working on controlled access data sets. You're able to explore more data than just what you bring in. You're also able to install software and bring in the latest tools through Conda and Docker. You can scale when you need to, when you want to run your analyses across many, many data sets and pay for that. And then you're able to collaborate really interactively with folks while you're doing this analysis to share it privately, and then also publicly once you're ready to publish that. So we've been working and collaborating with a lot of educators through the GDSCN and Biodig's project to develop resources for training folks on AnVIL in the classroom. A lot of this is work that I'm really proud to kind of represent and happy to point you to those if you're interested in using that in the classroom. And there are also many ways to connect outside of us in person, so I encourage you to check those out too. Thank you.
Hi, my name is Rebecca Hassett. I'm a software developer at Adams SQL's lab at Cold Spring Harbor. We're working on developing a bioconductor package with a comprehensive suite of tools for analyzing and simulating nascent RNA sequencing data, such as ProSeq and 4SU data. So functionalities such as estimating initiation, elongation rate, and pause escape rate data from read counts, simulating polymerase movement along a transcription unit using a continuous time Markov model, likelihood ratio test functionality, and also we definitely want to use AnVIL in the future because we're working on interpretable ML models to integrate into this package, capturing the relationships between rates and epigenomic and genomic features with our collaborator Peter Koo, and sharing some data that our collaborator is generating with temporal nascent RNA sequencing data using their new kinetic barcoding approach. Thank you.
Hey everybody, my name is Sofia. I'm with the Broad Institute, formerly with BUMC. And so as you all might be aware, there are other NIH-funded repositories that exist besides AnVIL, although AnVIL is obviously the best. And there's actually almost 150 of these NIH-funded repositories, and the NIH has spent over $6.7 billion in the last decade developing these across 27 different institutes and centers. And so the development of these repositories has enabled secure data sharing for secondary research use and has really encouraged that over the years as well. But we might be at a point now where we have too much of a good thing. So maintaining all of these repositories means redundancies in maintenance and operation. And it also means keeping the data disparate, which makes the data harder to find. And that is not very fair, or the F in findability, accessibility, interoperability, and reusability. So the key question is, how can we increase fair data sharing while minimizing the costs and redundancies? You can come find me at poster 11 to find out. Hi again. Okay, so as you all know, researchers, when they're looking for data for conducting secondary research, they are identifying data sets that they think might be good targets and will be usable for their research. And then beyond just identifying these data sets, they also need to see if the data within the data set is going to be usable, right? So does it have the right file types? Maybe if they need ICD codes, does it have ICD codes? How complete is the data? And in order to do this, the researchers often have to access the data, which requires a data access request. And then they have to wait somewhere between days to, hopefully not, but months to access that data and then familiarize themselves and make the actual assessment. So when you multiply that across the potentially like tens of data sets that researchers are evaluating, they're spending too much time figuring out if data is usable versus actually conducting the science that's going to advance human health. So how might we expedite and simplify this data evaluation and screening process? And how can we ensure higher rates of effective data use post the data access request? Come chat with me at poster 12 to find out about VODAR, one potential solution.